Welcome everyone to the AOML Science Seminar. Today's presentation is by Dr. Sim Aberson. He's a meteorologist with the Atlantic Oceanographic and Meteorological Laboratory located in Miami, Florida. Today he's going to be speaking to us about Hurricane Andrew, then and now. Sim, take it away.
Okay, this is an extended version of a talk I gave at the AMS History Symposium a couple of months ago, and I want to thank my co-authors and some other people that I talked to a lot about what went on during Hurricane Andrew. So Neal Dorst here at HRD, Robert Maletta at the Weather Forecast Office, and Dan Brown at the Hurricane Center, and also Frank Marks, Peter Dodge, and Joe Griffin here at HRD, who did a lot of the work here that I'm presenting that's about 30 years old. So just a reminder, Hurricane Andrew, it was just over 30 years ago now, and it was a long track Cape Verde hurricane, Category 5 hurricane when it hit the southeast coast of Florida, but it was also during a very inactive year in the Atlantic. It was in late August, and it was the first storm, and the rest of the season besides Andrew was very, very inactive. So just to show it only takes one hurricane to make a really bad season. Just some background, Andrew was the most destructive hurricane to hit Florida in terms of the number of structures damaged or destroyed. It still holds that record. It was the costliest hurricane to hit the US in constant dollars for the next 13 years. So that doesn't account for inflation. So given inflation, some storms have surpassed that, but that was quite a record to hold. And it's one of only four Category 5 hurricanes to hit the US on record. So here's some images that were taken, some of the destruction in South Florida on the upper right, and a satellite picture when the eye was over southeast Florida, over Biscayne Bay at landfall when it was 926 millibars, and a radar image from the old radar, and I'll talk a little bit about that in a few minutes. So after the storm, Roger Wakimoto and some other scientists, Nolan Atkins and Greg Forbes, they did some aerial surveys to look at the damage to try to assess what happened. And they made these plots. The red shows the direction of the first wind, and the green shows the direction of the second wind, the damaging wind, after the eye had passed. And here you can see the track, and that the center of the hurricane passed right over Homestead Air Force Base. First the northern tip of Key Largo or Elliott Key, actually, and then Homestead Air Force Base, Homestead General Hospital, and then into the Everglades. And so this shows the direction of the damaging wind and some of the wind speeds. And this one also shows some of the wind speeds. And you can see in the solid blue the area of the most extreme damage. So they took the damage from the winds and tried to equate that to the tornado scale, the Fujita scale. And so they found F1, F2, and F3 damage in some areas around Homestead Air Force Base. This image here was an image that was made at HRD from the radar that was on top of the Hurricane Center, which then was located in Coral Gables. You can see in the top center there's a plus and it says NHC. That's where the Hurricane Center was located, across the street from the University of Miami campus, with the radar on the roof, the radome on the roof of that building. And this is what the hurricane looked like. It was a very, very small hurricane, mostly just this one donut ring of convection. There were a couple of weaker bands. It was a very tiny hurricane, and it was mostly a dry hurricane because there was very little convective activity outside of the eye wall here. In the back of that image, HRD and text put together by some scientists at HRD, Stan Goldenberg and Mike Black, and some information on the hurricane, which was subsequently upgraded to Category 5 after this was made at landfall. So this is the original document. So, you know, I titled this Then and Now, and I just wanted to go over the sort of information that we had available to us, observations at the time then and what we have now. So back then, GOES-7 was the satellite that we had available. There was GOES-7 was the only GOES satellite available at the time because GOES-G failed and there were delays in GOES-I. So it was located at 112 West, which is doesn't reach the Eastern Atlantic very well. So we had to rely on the hurricane forecasters had to rely on Meteosat satellites to see what was happening in the Eastern Atlantic where Andrew developed. The resolution of that satellite was 14 kilometers, and the visible resolution was about 4 kilometers for the full disk imagery. And the full disk scans were made every half hour, and they took 20 minutes to complete. So, you know, we didn't get very many full disk scans to see what was happening throughout the entire hemisphere. There was no to limited microwave imagery or scatterometry at the time, and there were also limited cloud motion vectors at the time because of the relatively low resolution of the imagery. And just to compare that to now, we have the two GOES satellites 16 and 17 that are up there. The resolution is much higher, 2 to 4 kilometers, and a half-kilometer visible scan for the full disk imagery. And those scans are now made every 5 to 15 minutes, and the CONUS continental US scans every 5 minutes. And we can even do rapid scans over things like a hurricane or mesoscale complexes every 30 seconds. So it's amazing how much more satellite data we have. And now we have very common low Earth orbit satellites that give us a lot more information, scatterometry and microwave and sounders. And there's, due to the high resolution of the visible imagery, we get much higher resolution atmospheric motion vectors as well. And what did the satellite imagery look like at the time? Now, this is this was placed on a VCR tape. This is what we had available to us in real time, and we animated it. And we got this off of the VCR tape. This is the water vapor imagery that we got from the Meteosat. And I'll play that again, and you can see the relatively low resolution as compared to what we have now. There was this cold low off to the north. Here's Andrew fluctuating in intensity as a weak tropical storm, and this cold low, sorry about that, this cold low at the top was shearing, putting some shear over the top of Andrew, so limiting its development. And a little later on, we even used the Meteosat imagery just about over to Florida because the GOES satellite was located well to the west over near California, the longitude of California. And here you can see Andrew getting sheared and then turning to the west and developing this pinhole eye and moving toward the northern Bahamas. And that cold low had moved off to the north. But still, it was a very, very tiny storm. And I couldn't find the image to put on this, but we have an image of Hurricane Andrew and Hurricane Hugo that occurred just a few years earlier, 1989. And just about all of Hurricane Andrew fit into the eye of Hurricane Hugo at landfall. So Hugo was a large hurricane and Andrew was a very small hurricane. And then finally some GOES imagery, and you can see it fluctuating as it hit Florida and then redeveloping and making landfall as a strong hurricane again in south central Louisiana a few days later. But note the relatively low resolution of the satellite imagery that we had available to us. So we also had Doppler radar. Well, not at the time. We did have radar that I showed you before. There was the radars that were mostly available at the time were the WSR 57 radars. The first of those type of radars was actually installed in Miami at the Hurricane Forecast Center, and it was moved to its location in Coral Gables in 1967. It had only reflectivity, there was no Doppler, and there was no data recording. So what HRD did at the time is they wanted to get a lot of the radar data during landfall events. So they developed a system where they took a PDP 1123 computer, which is shown here in the center bottom of the slide. It was pretty big. It would reach up to my chest, and we had these in blue cases. I think they were watertight cases that we had to put on commercial aircraft and take with us to different sites that had the radars, and then we had to plug them in and record the data. And along with this, there was a custom digitizer and a 9-track tape drive, and it recorded the data. And remember, this was also before some common graphical formats like GIFs or JPEGs were readily available. So not only did we record the raw data, but we had to transform it into graphical format. There was, the new radar was called NexRad, WSR-88D, and that's essentially what we have now. There was the first one, one of the first ones was installed in Melbourne, Florida, and it was able to see Hurricane Andrew's landfall at in Miami from Melbourne, but it was outside the range of the Doppler. So it wasn't very helpful in getting any Doppler data during the landfall, except in the extreme northern part of it. Thankfully now the data from the NexRads is recorded. It is high resolution, up to a quarter kilometer, and it has dual polarization to distinguish between precipitation type. But the change from the 57 to the 88D is quite astounding, and where the upgrades to the 88D are occurring as well. Different aircraft that we have. Back then in 1992, we had the Air Force C-130 Hercules. They were retired around 1999. Some of the instrumentation that they had on their aircraft, they had Omega drop-wind sondes, which were the precursors to the current GPS sondes, although they reported data much less frequently. The current drop sonde is a 4 sonde hertz sending data back. The Omega drop-wind sonde, I don't know exactly the resolution, but it was more than, it was multiples of hundreds of meters on its descent. That came back to the aircraft, and then we had to code those up into what we call temp drop messages, which had just the mandatory and significant levels like the old format for the Raywin sondes as well. They also didn't work in cloud, so we couldn't take any get any information from the eye wall, but we could get pressures from the center, and that's mainly what it was used for. Although we're able to get some information on the environment in this case as well, and I'll talk about that in a few minutes. And very importantly, the data from the C-130s was transmitted by a radio voice link. So the only way to transmit the data was by voice. The NOAA had 2 P3 Orions, and they still have those. They're still in service. The instrumentation that they had on the aircraft, they had the same Omega drop-wind sondes, the same system. On the belly there, you can see a radome. There was a lower fuselage radar, and we could send, we could do composites of the radar and see what was actually going on. There was also the tail Doppler radar, which you can see on the back. which we recorded and really didn't do anything in real time. It was difficult to make analyses of that data for a long time without a lot of work going into them. We also had flight level data that was sent back every 30 seconds, and all the data were transmitted by what we called the aircraft satellite data link. And it was a new link, and we had about 30 seconds every half hour to transmit a very small packet of data to the GOES satellite, which was then transmitted back to the ground from the satellite. And that's how the data were transmitted at the time. And it was the first time we were actually able to transmit any of these data outside of the voice. And current upgrades to that have occurred since then. So the aircraft flew many. Frank says the ASBL was transmitted at 100 baud, and that was extremely slow. The aircraft did fly many missions into Andrew. It wasn't until Andrew passed well north of Puerto Rico, between Puerto Rico and Bermuda, that aircraft reconnaissance began. There were 14 Air Force reconnaissance missions and a two-plane NOAA mission that went into the hurricane, the tropical storm and the hurricane. There were a total of 91 center fixes, and I plotted them here. So you can see there were a few north of the islands. When it approached the Bahamas, they became much more frequent until landfall in Louisiana. The two-plane mission that NOAA did took off from Miami, where the planes were based at the time, and they did a synoptic flow experiment. And what that was beginning in the early 1980s, Bob Burpee and Joanne Simpson talked about uses for the drop zones, the ODWs, and came up with the idea of once they realized that one of the reasons that a lot of forecasts of hurricanes failed was because there was no data over the open ocean. They decided to take the planes out, fly as high as they could, and drop these sondes and get wind and temperature and humidity information to put into the models and try to improve the models. And so we did this once in Hurricane Andrew, where I have this blue arrow pointing. It was 2 days before landfall. At the time, we thought it was about 3 days before landfall. There were 49 ODWs that were released and the data sent to the ground for assimilation into the models. And in fact, the data didn't actually get assimilated into the global models at the time because they didn't have the capability to do that. But there was one model where we assimilated that, and that was VICBAR. And that was my job, to take all of the data, the flight level data that came across the ASDL and the temp drop messages, and decode them and run an analysis that VICBAR could run. So speaking of the models, here on the right is a plot from NHC on the various different models that they've had over the years and how they did. I have a vertical line here in 1992 showing the state then, and you can go to the right and see how much better the track forecast models are than they used to be. Back then, the models were run only twice daily. We did run VICBAR 4 times daily because we had full control over it here at HRD. But the other models were mainly twice daily, especially the global model and the dynamical models. The ATCF wasn't yet available, so they really didn't have a comprehensive system to look at the models. It was difficult to track the models. Sometimes they did it by hand. We didn't animate stuff very easily, and those animations weren't freely available. This is mostly before the advent of the internet. I mentioned VICBAR. VICBAR was a barotropic analysis. It was a nested spectral model. So we could go to very high resolution in the inner core, up to what we called very high resolution back then, 50 kilometers, which is laughable now. But we were able to make analyses by incorporating all the aircraft data to create an initial vortex. And as a result of that, you can see VBAR on this plot as the purplish triangle, and you can see that it was one of the most reliable models at the time. Other models that were available were the BAM, which is Beta Advection model. So you put a point in the low resolution version of the global model and let the winds advect it, and that would be your track forecast. NHC 90, which was the one of a long line of statistical dynamical models that took statistics of what was going on in the atmosphere and made a forecast. There was a relatively high resolution numerical model called the QLM quasi-Lagrangian model. I think that was over 100-kilometer resolution in the core at the time. Very expensive to run. It had a bogus vortex. And it somewhat created good track forecasts as well, but we didn't get intensity forecasts. And in 1992, the aviation model, as it was called at that time, was the global spectral model. It was T126, so it was about a more than 150-kilometer resolution and 18 levels. And they had just instituted a synthetic vortex, which was actually based on some of the research we did at HRD on the VIC-bar initialization. And on this plot, you can see the trends in the official forecasts over the years. So on the left, you can see there's a vertical line at 1992 showing how accurate the track forecasts were. We only ran the models out to 72 hours as opposed to much longer now. The GFS has run out to at least 10 days and even longer now. But one thing to note, if you look at the 24-hour forecasts back in 1992, they're about as accurate as the 72-hour forecast now. So, and then the 48-hour forecasts, where you want to have at least the hurricane watch up, if not getting ready to put a hurricane warning up, they're as accurate as the 120-hour forecasts now. So it's amazing to me how much improvement we've had. And, you know, I wouldn't be able to make decide on what would be a hurricane watch or hurricane warning area based on our current 120-hour forecast accuracy. But the hurricane specialists at NHC had to do that, and it's kind of amazing that they did. You can look here at the intensity forecasts, and the 24-hour intensity forecasts are also about as accurate as the 48-hour forecasts back now. But the 48-hour forecasts back then are less accurate than even the 120-hour forecast. So the forecasts have been improved quite a bit, and I'd be hard pressed to make forecasts now, given the back in 1992, given how accurate the forecast models were then. And just to give you an idea of some of the forecasts that we had at the time, this was when Andrew was before depression status. It was before they called these things invests. NHC had a thing called a storm card that they sent to the central computer, and we were able to get the storm card and run VIC-bar, and the other models were run automatically. And they didn't call them invests; they just called them XXXX. And you can see here that there's Clipper and NHC 90 and BAM and VIC-bar. And as expected, most of the storms move off to the west, west, northwest, and that's what the forecast said, and that's actually what happened. But you can see even here there's a pretty strong spread in the forecast models. The BAM had the forecast going toward Barbados, but it looked like VIC-bar was going to go north of the islands. And we actually had the first QLM forecast then, when it was still a pre-depression. 24 hours later, we have Andrew as a tropical storm, and the model spread is still huge between, you know, Guadeloupe or Martinique on the south and recurving north of the islands to the north. And that was what it was like back then. We had very large spread. And note these are original plots. You can see the local time that it was actually plotted. This was software written by Bob Kohler at HRD at the time, and it had a timestamp of actually when it was plotted. And a few hours later, just about all the models had it going north of the Leeward Islands, and it was starting to get sheared, and that trend continued. VicBar tended to have a northerly a bias toward recurvature because it was a deep layer mean, and if you had an upper level low and a system would get sheared and turn to the west, VicBar couldn't catch that. So that's why VicBar was so far north of the other models. But the other models, kind of also agreed that it would go north of the islands. And this is the classic track bifurcation that we used to get a lot. We don't get it as much anymore in the global model ensemble. Sometimes you see this, but some of the models turning off to the west and some of the models recurving. And then that trend continued here. And what's interesting is here now we have the AVNO plotted. And this, I believe, my recollection is that this was when they upgraded the model to put in the bogus vortex. So it actually had a vortex that could be tracked, and it did track it, and it produced a 72-hour forecast. And notice that it was pretty much to the south of just about all of the other models. And most of the other models, except for the BAMP, actually continued to show recurvature. Continuing here, you have the two dynamical models, the QLM and the GFS, having it hit the northern Bahamas. VicBar is turned off to the west, and that was interesting. That upper cold low passed to the north, and the storm looked like it was going to turn to the west. But huge spread here, and looked like it was 3 days away and could head anywhere between Florida and North Carolina or recurve. Just 12 hours later, now the models start to agree. They're turning to the west, and it looked like it was going to hit somewhere in Florida. This was before the rapid intensification began. Note still that the GFS was quite a bit to the south of the other models. And then 12 hours later, the forecast sped up. So 12 hours earlier, Andrew was more than 72 hours or even 4 or 5 days from landfall, according to almost all of the forecasts except for the NHC 90. But 12 hours later, the 48-hour point of some of these models was on the east coast of Florida. So quite a big speed up. And that happened a lot in the models. The models did a lot of windshield wipering, a lot of changes from time to time. Then just 12 hours later, this is when we had the synoptic flow experiment. So I was at the Hurricane Center. The data came in. I ran VicBar, and VicBar was available around 2:30 to 3 o'clock in the morning. So the 0Z forecast was available 8 to 10 hours or after the synoptic time. And that's how long it took to run these models at the time. The BAM Deep and the NHC 90E, the early runs, were a lot quicker because they used the previous global model. But the actual dynamical models took a lot longer to run. So the models sped up, and they were all agreeing on a South Florida landfall, and then a landfall eventually in the area of Louisiana. And I remember being at the Hurricane Center that night, and not only did the forecast models come in around 2:30 or 3 o'clock in the morning, but also we had line printers where the satellite data came in, and we were watching the satellite data come in on these line printers. And each satellite image every half hour was coming in and looking stronger and stronger. And there wasn't any reconnaissance in Andrew after the NOAA flights for quite a few hours. So we didn't have any in situ data, but the satellite made it look like it was rapidly intensifying. And, you know, I realized, well, this is probably going to hit South Florida. So I very early in the morning, I started calling friends and telling them they needed to get to Home Depot and get their supplies ready because it was rapidly intensifying. And by the next day, everything was mayhem in South Florida. And 12 hours later, the models continued to speed up. And so from going from 48 hours earlier, having the landfall in about 84 hours, and then speeding up by about about 2 days, 1.5 to 2 days, was quite a change, and it created some problems in the preparations, especially since South Florida hadn't really experienced a hurricane in close to 30 years. So some pictures from the Hurricane Center that I was able to find. This is from HRD workers at the Hurricane Center. A lot of them were there because they evacuated their homes. There's Bob Burpee and Jose Fernandez Partagas, who a lot of us remember for spending a lot of time at the Hurricane Center and at the library in Rasmussen doing a lot of historical work on hurricanes. And I believe that's Ed Rappaport in the foreground, if I'm not mistaken. And you can see some of the old displays and the radar display there from South Florida in the background. And just some of the aftermath for those of us at AOML. This is what the parking lot looked like afterwards. You know, we were outside of the radius of maximum winds. I showed on that earlier plot that there was a lot of destruction on the southern end of Key Biscayne, and there was a very strong gradient. And it was mostly trees down by the time you got north to AOML, but there was a lot of destruction as well. There were leaks in our roof, and that took quite a while to get fixed. This is the view down our driveway toward the Fishery Center across the way. And here's a view from the entrance to the Hurricane Center when they went outside afterwards. This is the parking lot outside the Hurricane Center, and it just lifted up cars and, you know, did stuff like that. And even that was outside of the radius of maximum winds, but a lot of destruction. And some people from HRD who were at the Hurricane Center remember the Hurricane Center was on the 6th floor, and even though it was on the 6th floor, during the hurricane, they could see the water in the toilet sloshing back and forth because the building was swaying. So after the hurricane, we had gathered that we had taken the PDP computer to the Hurricane Center and gathered the data from the WSR 57. And we tried to animate some of these data. The images were created on an HP computer, especially to correct the aspect ratio. And after that, they were sent to a Commodore Amiga computer, which was connected to a VHS recorder. And using all that, they were the animations were put together. It was very time-consuming to do that. And we recorded the data on a VHS tape. And for those of us who are quite a bit younger than me, there's a picture in the middle of a VHS tape, in case you've never actually seen one. And so we put together this tape because I was sent to a special session of the AGU Fall Meeting in San Francisco in 1992 that was organized by Bob Simpson on Hurricane Andrew. And so we put together this VHS tape that I could take with me. And we had to make a lot of special accommodations with the AGU at the time just to get a VHS player and a projector to show this at the conference. It was one of the first times that was actually done, and it was a little nerve-wracking, but we got it done, and it was a good symposium. So here's the animation of the Miami radar. Now, Brian McNulty on his website has a better animation than this, and he told me that he took the individual images from the original and did some work on them and put it back together. So the one that's on the web is a little bit nicer than this, but you can see here. I'll play it, and you can see as the eye wall becomes evident over the western Bahamas, and just the donut shape, and a couple of bands, very, very small hurricane, and moving over South Florida. And there's the famous last image. And here's a faster animation as it moves. And well, there's that last image. And I'll stop this for a second, because that last image was when the radome was actually blown off the roof of the Hurricane Center. I showed the damage to the cars on the bottom of the building, but the radome, I believe, was blown off the building, and that partial image here, which I'll try to, yeah, there, that partial image was the actual last scan of the old 57 radar. So right as it was over landfall, and you can see where the Hurricane Center was located here was outside of the eye wall. So it's well outside of the radius of maximum wind speed. To continue on here, another thing that we did with this, the animations, is they were able to make the animations with the looking at the inner eye wall structure, following the storm, doing a close-up, and only plotting the reflectivity that was less than 30 dBz. So that's what we're showing here. And this is really interesting, because it was looking at some of the eye wall features that you could see rotating around in the eye. This is the first time we really saw a lot of those features rotating around in the eye, and led to a lot of research that's still ongoing about mesoscale vortices and mesoscale vortices in the eye wall. But one thing I want to highlight on this, if I can, is that when we were animating this, and we looked at these animations for the first time, this little plus wasn't here, but we noticed that there was something moving through the storm. And I can go back just a little bit and then show it. If you watch this little plus going through the eye, we were wondering what that was. And it took a few years to figure it out, and Sam Houston did a lot of work on this to figure it out, and it was actually a ship that thought it could outrun the hurricane, because it thought the hurricane was moving a lot slower than it was, but it actually went through the eye of Hurricane Andrew as a Category 5 hurricane before landfall. It did suffer a lot of damage, and there were a lot of injuries on board. I believe it limped into Port Everglades later on, and the shipping company tried to keep it quiet, and somehow Sam was able to track it down. So it's interesting, all the different things you could see on these radar images, but there's you can see all this interesting structure along the inner edge of the eye wall that was hypothesized to be some of the very small scale features that created all the wind damage when Andrew made landfall. So not only did we animate the radar, but we also animated the model forecasts. So here's some streamlines from the model, and the quality isn't good, but that's what was available at the time to us. And you can see we could see the change from the upper low to the north, and then the subtropical ridge to the north. as as Andrew moved to the west. It's rerunning here, and you can see here's that upper cold low, and then the subtropical ridge moved into the north and allowed the storm to go to the west. But this is one of the first times that we actually saw animations like this. And we actually sometimes even had color. So we were able to have a few colors in our very early graphics. This was the vertical shear over the storm, and we were able to animate things like vertical shear. This was as they were first starting to develop ships, and we were looking at things like vertical shear and other parameters and trying to animate it. And we only had these every 12 hours, but we were able to do that. So I think this plays one more time. So not only was it difficult to put this onto the VHS tape, but in the last year it was difficult to get it back off the VHS tape so we could show it here. Now, some of the other upgrades that have gone on, not at HRD, but with the Hurricane Center. So back then, before the internet, all the products were in text and they were all in uppercase. They had no wind speed or storm surge probabilities. There was no social media, no smartphones, etc. They had 4 products: the public advisory, the marine advisory, the discussion, which was labeled at the time for intergovernmental use only. And they just started a couple of years earlier, these strike probabilities. But some new things that they have now, there's all sorts of different public products. In the mid-1990s, the website came on. In 2001, the cone graphic came online, for better or for worse. And on the upper right here is an example of what the cone graphic for the official forecast would have looked like as they put up hurricane warnings before Andrew, but these graphics weren't available at the time. In 2005, there were wind speed probabilities and probability maps, and here's maps of what those would have looked like for Hurricane Andrew at the time. In 2007, they added the graphical tropical weather outlook. In 2013, they extended that to 5 days as well. In 2011, they NHC got on social media, and then in 2015 they added the key messages. And we didn't have that back then. There was just what was reported in the advisories. So now they have the key messages, and here's an example. They wrote up what it would have looked like had they had the key messages back then, that the confidence in the forecast would be pretty low, etc. But that was unavailable at the time. Other products, the potential storm surge flooding map. Here's an example here of what they would have been able to provide if Hurricane Andrew arrived now, and also the time of arrival graphics that are on the bottom here, and also storm surge watch and warnings. There have been a lot of upgrades to the aircraft. The next year, we were actually able to transmit the radar reflectivity images from the P3. And in 1995, the H-Wind group here at HRD started putting together real-time surface wind analyses. In 1997, the Gulfstream 4 aircraft replaced the P3s for the synoptic flow experiments, and we got the new SONs, the GPS SONs, that were much better. 1999, the C-130Js began to replace the H's. And also that year, the first transmission of the SFMR surface wind speed and rain rate data. So now we have actual measurements of what was going on at the surface for the first time. In the year 2000, we started doing targeted observations from the G4 to improve the track forecasts. 2005 was the first transmission of real-time Doppler wind analyses. Back in the 80s and 90s, it used to take like months and months for a person to do an analysis of the Doppler radar for one pass through the hurricane, and then we were able to do them. By 15 years later, we were able to do them in real time on the aircraft. So it was pretty amazing change there. In 2007, the SFMRs were installed on the Air Force aircraft, and they started to transmit the data. In 2008 was the first transmission of the airborne Doppler radar data for assimilation into the models. 2014, uncrewed aerial systems into the core of a hurricane. 2017, the major overhauls of the P3s were completed, and hopefully they'll be around for a few more years at least. And in 2023 or 2024, hopefully the new Gulfstream 550 will replace the G4. The models, as I showed, the models have improved quite a bit. The ATCF is now available. Model fields from global models from many different centers, they're shared on the internet, and everybody can look at them, and easy to animate them, and easy to figure out, what you want to see and plot different things. It's very flexible systems that people have put together. Just huge improvements to the model systems, model resolution, physics, the data assimilation, and the post-processing. So, there have been great strides, but it doesn't mean that disasters like Andrew aren't going to happen again. And here's some examples that have happened since Andrew. So, we still need to improve these forecasts and improve the resilience of our communities. So I think that's my last slide, and I will end there. And I saw there were a huge number of comments, and I'll take any questions if anybody has them.
Thank you, Sim. This has been a great trip down memory lane for many of us, and likely for some of the younger scientists or new folks in the field, just seeing how far we've come from 30 years ago, 31 now years ago, in our research innovations and in the science. So there are many anecdotal and a lot of comments from people here. I did see one question early on from Rob Rogers on the model when you were showing the models, and he was asking how much more spread is that when with what we see for now for weak systems. Does that seem, he says that doesn't seem huge to him.
Yeah, I mean, I could quantify that. I think there's more agreement. It isn't as questionable now whether a storm is going to recurve or not. A lot of times we have little spread and sometimes we have big spread. I think back then we almost always had large spread. I think the spread has decreased as the models have improved, but we still can get very large spread, especially for slow moving storms that sort of look like the spider on the maps. But for a system that was moving 20 knots, we usually don't see huge cross-track spread like that anymore, but it still does happen. Yeah, and I see Rob Rogers also asked about the infamous Enjoy Your Weekend. That was Friday evening, and that was a comment from, I believe, Bob Sheets at the Hurricane Center, that Friday evening when they were forecasting more than 3 days for landfall in Florida. He said, enjoy your weekend and we'll revisit this, revisit the hurricane later. And of course it hit in 48 hours. So that didn't work. It still happened at that time.
Thank you,
and
Sam.
Dave Nolan mentions the very low confidence that we had in the forecast, and that's obvious because the average errors were so large. And one thing I neglected to mention is I kept showing that the GFS, the AVN at the time, had this leftward bias, and it was very good forecasts. And it was the first storm that it forecast. And we were like, oh, this is really amazing that the global model can forecast. Well, all the storms after that, it didn't do a good job. It had this huge leftward bias. And that was because of the bogus vortex that we put in there. It happened to be right during Hurricane Andrew for the wrong reason. But gave us some confidence that we shouldn't have had in those forecasts.
So as you read through those comments and stories from folks, I welcome folks to raise their hand maybe, and we have a couple minutes here left if someone wants to share a story or maybe ask a question. to Sim. Stan, go
Stan
ahead.
has a question.
Yeah, I'm glad you emphasized the whole issue of communications, because wow, I mean, people could only get it through the TV, and I don't believe we had 24/7 news then or anything. But of course, I'm quite experienced with Andrew. I wish I had a way to just show it, but I've got a picture of that Andrew. It's the eye of Andrew inside the eye of Hugo, not all of Andrew. And also I've got in the National Geographic special, I can put the link in the comments. It shows not only shows that picture, Mike Black and I looking at it, but it shows the reenactment of the famous moment on Friday when you first showed me the VICBAR forecast that started to bend it towards Florida when I was about to go home because our fourth child was due. So they did that whole reenactment and picked it out and stuff. And so much, but it's mind-boggling. I looked at this back in August, it was the 30th anniversary, and it was just amazing how far we've come. And back then we didn't think we were in the Stone Ages. We thought a lot of things were great, but it's just absolutely amazing. So thank you for putting this all together. If I could upload pictures to chat, I would, but.
Yeah, and as I showed on the first slide, it's AOML's 50th anniversary, so we're collecting, oral histories and things like that. So if people have things that they want to contribute, you can send them to me and I'll pass them along. The other thing I wanted to mention is I gave this a shortened version of this talk at the AMS meeting in Denver, and that recording is available now only for people who registered for the meeting, but it was paired with a talk by Jack Bevan on a ship that went through another Category 5 hurricane in 1944. And then we had about an hour available for discussion. There was a lot of discussion that's recorded on that, with including with Brian Norcross, who was there telling a lot of stories. So it was a very interesting recording that once it becomes available, if people are interested, they should listen to it.
Any additional questions anyone has, please raise your hand or type it in the chat. All right, not hearing any, I will stop the recording. So thank you for joining. And if those that want to stick around a little one, then yes, there was a question about getting the presentation. Please contact Sim Aberson for that. And we will have this recording up on the AOML website /seminars page. So that will be available. Thank you again for joining.